Okay. Okay, so we're gonna start 5.3. So let's start. So the perpendicular segment from a vertex of a triangle to the line containing the opposite side is called the blank. So when we did in 5.2, we went over 2 points of concurrency. We went over the circumcenter and the incenter. So your circumcenter is the point of concurrency of perpendicular bisectors. Your incenter is the point of concurrency of angle bisectors. Your centroid is the point of concurrency of medians. And your orthocenter is the point of concurrency of altitudes, okay? So one important thing to know about medians and altitudes is that it's a line segment or a line, depending, that will start at your vertex, okay? So when you see the perpendicular segment from a vertex, that's already your clue to start thinking, okay, it's going to be centroid or altitude. Like, let's see which one. That should be your first initial red flag. That should be like your first, like, okay, maybe it's going to be this. And now let's keep reading. So the perpendicular segment, okay, perpendicular segment. What do we know about altitudes? Altitudes is from your vertex to a line containing the opposite side at what angle? At a 90 degree. So what's another way of saying 90 degrees? Whoops. Perpendicular, correct? So the perpendicular segment from a vertex of a triangle to the line containing the opposite side is going to be called the what? Altitude. Okay. Now, what about your median? What does your median do? That one I feel like you guys got really, really well. Your median starts at your vertex and goes to the midpoint of the opposite side. So a median starts at a vertex, and it's a line segment starting from your vertex to the opposite side of that angle at its midpoint. Okay? That's a median. An altitude is starting at your vertex to the opposite side, but does not always have to cross the opposite side exactly. It has to cross a line containing that opposite side. And we're going to see what I mean by that more specifically in a couple minutes. So let's just finish answering this question. A segment whose endpoints are a vertex and the midpoint of the opposite side is called a median. Okay? So the point of concurrency of medians is called the centroid. We already did that. We just talked about that. And the point of concurrency of altitudes is called the orthocenter. Okay. So let's look at 5 points. Okay, so one important thing to know about medians. What do we know about, or one important thing about medians is that, okay, so medians, so L, okay, so they told it, let's just take a look at this one. So in DEF, C is the centroid. Okay, so if C is my centroid, then that means I know, what else do I know? If C is my centroid, that means that from F to C to L is the median. And what do I know? That's the whole median. And what do I know about a median? It starts at a vertex, F, and goes on to the midpoint of the opposite side. And now I can say the same thing for this one. And this guy. Okay. So the other important thing to know, let's just focus on LF right now. Line segment LF. From my vertex to the centroid is 2/3 of my entire median. From my centroid to the midpoint of the opposite side is 1/3 of my entire median. So if my entire median was 30, what is my LC? What is 30 divided by 3? What is 1/3 of 30? 10. What is 2/3 of 30? 20. Okay? Now, if they give me my LC, let's say they say that my LC is 5 and they want me to find my entire median and my CF. So let's just first say CF. So if they give me that my LC is 5 and they want me to find my CF, How did I go from 1/3 to 2/3? What did I have to do? I had to multiply by 2. So I'm gonna have, oh, let me put a dot. I don't like that x, right? Now, so if my LC is 5, what do I have to do to get from 1/3 to 2/3? I have to multiply by 2. I have to multiply by 2. So what would I need to do to get from 5, the LC, to the CF? I need to multiply by 2. What's 2 times 5? 10. Now, what if they give me, oh, and obviously, guys, what do I have to do to get from 1/3 to the whole 1, as in the whole median? I have to multiply by 3. So if my LC is 5, what's my entire median? 15, because I have the 5 here and the 10 here. Now, if my CF is 20, how do I go from 2/3 to 1/3? I have to divide by 2, correct? So what is 20 divided by 2? 10. And what is my whole median then? What's 20 plus 10? 30. Okay? So my whole median would be 30. Okay, so that was just a review of things that you have to know. So now, if CM is 8, find DC and DM. So another problem that you guys would have, and I don't know, I think it's very convenient that they're drawing it to scale, but they don't have to. This MC is your 1/3 portion. But why? Please don't say because it's a smaller side. It's because this is the 1/3 portion because the endpoints are your centroid and the midpoint of a side of the triangle. That makes it your 1/3. And then this from C to D makes it your 2/3 because it's from the vertex of a triangle to the centroid. So it makes it your 2/3 version. So if my CM is, what is it? CM is 8. So if my CM is 8 and my 8 is 1/3, how much is this 2/3 portion going to do? What do I need to do to this 1/3 to get 2/3? I have to multiply by 2. So I have to multiply the 8 by 2, which is what? 16. So my DC would be 16. And my DM, what's 16 plus 8? 24. Right? Or if I didn't want to do the adding, I could have also recognized that if CM is 8, how do I go from 1/3 to a whole? I have to multiply by 3. So what is 8 times 3? 24. Okay? So let's take a look at this one. For triangle ABC to the right, is the red dashed line an altitude, a median, or neither? Okay, so let's see. So my red line is starting at a vertex, at vertex A. Okay, so I know it's starting at vertex A and it goes to the other side of the triangle, to a line containing the other side of the triangle at what? At a perpendicular. So what type of line is this? Or what type of segment is this? It's an altitude. Now the question is it an altitude because of D or is it an altitude because of A? Well, is it an altitude because it is perpendicular to a side? I mean, it is perpendicular to a side, but is that why it's an altitude? I don't know. Let's keep reading. So altitude, let's look at D and see if it's a better answer. So altitude, because it extends from a vertex of ABC and is perpendicular to the opposite side. That's my answer. Okay? So my answer is D. We've already gone over that a lot in class, so I think we're good with that one. So let's take a look at this. For triangle ABC, is AB a median, altitude, or neither? So let's look at AB. Well, what do I know about AB? I know that it's a line segment. Where does this line segment start? Well, you could either say A or B, but let's just say B for now. Let's say it starts at B, right? If my line segment, well, a line segment can start anywhere, right? But that's not the point. So let's say that I'm looking at my BA, correct? What do I know about this right here? This is a vertex, right? What is the opposite side to this vertex B? What is the opposite side to this angle B, to this vertex B, angle B, right? What is the opposite side? It's line segment. It's line segment AC, is it not? Okay, So if this is the lines, this is a line containing line segment AC. Is A on AC? Yeah, it's literally on it, right? So what do I know about? So now if I have all of that, what do I know about a segment that starts at the vertex and goes to a line that's a line containing the opposite side? Was my opposite side AC at a 90-degree angle? That's an altitude. Okay, so please don't get confused by this question. This question is tricky. It can trip up a lot of people. So just make sure you take a step back and really analyze what you're looking at. You're looking at a line segment, BA. And what do I know about BA? I have a segment here, a vertex here, and it's going down to my opposite side, right? Is it touching a point on this opposite side? Yeah, right here at A. At what? At what angle? 90 degrees. So I know that it's an altitude. Okay? Altitude. Okay, so use triangle ABC shown to the right to answer the following questions. If BK is 17, what is KQ? Okay, so they don't really give me, they don't tell me if I have altitudes, if I have medians, if I have circumcenter. They don't really tell me anything. So I have to infer what they want me to look at. So let's take a look at this triangle. I'm going to erase this for now. So let's take a look at this triangle and see what type of triangle I'm working with. Okay, so I have a triangle. Okay, I have some sort of bisection going on. So the first thing in my mind is either perpendicular bisector or medians, because I'm having a bisection of line segments, correct? If it was a bisection of angles, I'd have in-center, right? Okay. So I'm looking at this B. So let's look at this B, this vertex B. What's happening to this vertex D? Okay, it has a line going to the opposite side. Yes, line segment AC is the opposite of angle B. And at what point specifically is it going to? If I have a if I have a tick mark and a tick mark there, then I know that Q is just a midpoint, which means that BQ, isn't that a line segment going from the vertex to the midpoint of the opposite side? Yeah. So that's one line. That's a what? A median. Correct? Now, let's look at A. From A to P at another midpoint. P is another midpoint. So right here, I have a point of concurrency of what? Of medians. And what is the point of concurrency of medians? A centroid. Okay. Now, C has nothing, so that does mean nothing. So C is useless. But I only need at least 2 to give me a point of concurrency, right? So now I have a centroid. What do I know that's special about a centroid? From the centroid to the, well, I actually like to say it like this. So I'm going to write this down, even though it should be written on your notes already. From your vertex to your centroid is how much? 2/3. From your centroid to your midpoint of opposite side is how much? 1/3. So now let's see. What's up with this. So now I know that from my vertex to the centroid is how much? 2/3. And I know that from my vertex to my midpoint of the opposite side is 1/3. Okay. So now let's see. So now I'm actually going to go back and look and see what's happening. So now if BK is 17, so BK is 17, what is KQ? Okay, well, if BK is worth 17 and 17 is 2/3, the 17 is a 2/3 portion, what do I have to multiply by to get my 1/3 portion? I had to multiply by 1/2 or divide by 2. I could have done either one, but I don't want to divide fractions. I'm going to multiply by its reciprocal. So instead of dividing by 2, I'm choosing to multiply by 1/2. So this is going to cancel out with this. What's 1 times 1? 1. What's 3 times 1? 3. So if I divide this 2/3 portion, which is 17, divided by 2, or let's keep it consistent, let's multiply by 1/2, I would get my 1/3, my 1/3 portion, my KQ, which is what? 17 divided by 2. You just multiply straight across. 17 divided by 2 can also be written as 8.5, right? So either way, I will accept any answer, 17 over 2 or 8.5. It doesn't matter, okay? So that's your answer to KQ. Okay, what is this? Okay, so now let's look at this. Use the diagram to the right to find the length of PD, okay? Point B is the centroid. Okay, perfect. They didn't actually have to tell us that it's the centroid, because I know that I'm starting at a vertex and I'm going to the opposite side at its midpoint. So they really didn't have to tell us that. They kind of went easy on us, right? You see here I'm drawing all the... So BD is a median as well as an altitude, okay? There's nothing wrong with that. Nobody said they couldn't be. But BD right here, let's just take a look at the fact that it's a median, okay? So now, what did they want me to find? The length of PD. Okay, so let's look at this. Perfect. So let's look at this. So in this line segment, PD, which is a median, from my vertex to the centroid, my centroid P is how much? 2/3. From my centroid to the midpoint of the opposite side is 1/3. And they want me to find my length of PD. So if 72 is 2/3, what do I have to do to 72 to get the 1/3? I have to divide by 2 or multiply by 1/2. What is 72 divided by 2? 36. That's it. That's my answer. Okay. Let's look here. Okay, so name the centroid of the triangle. So they want me to find the centroid. So let's work backwards. In order to find the centroid, what do I need? Medians. I need a point of intersection of medians. How do I find my medians? My medians start from my vertex to the midpoint of the opposite side. So let's take a look at some vertexes. So look at my R. Does my R starts at a vertex and goes down? Is he a midpoint? Yes, it is, because of the 2 tick marks. So I know. So I'm gonna draw this right here, like that. Okay. Now let's look at my S. Does my S have any lines? Doesn't have any line segments coming off of it, so that's useless. Let's look at T. So T starts at a vertex and goes to the opposite side. Tick mark, tick mark. So I'm good. So that's also a median. So I'm going to do that. Where is the point that these 2 blue lines intersect? V. So that means V has to be my centroid. Whoops. Okay. Let's take a look at this one. Name the orthocenter. Okay, so my orthocenter, I need to work backwards. For my orthocenter, I need altitudes. And I know that altitudes are lines that start at the vertex and go to the opposite side at a perpendicular angle. So let's take a look at some of the sides that we have. Okay, let's take a look at S. So S is definitely a vertex, duh. And it goes down to the opposite. What's the opposite of angle S? Line segment TR. Okay, at a 90 degree, does it? Yeah, 90 degrees right here. So this is my first altitude. Okay, let's take a look at my T. So my T is a vertex. There's no 90 degree over here. So it is not an altitude. It is actually, in fact, a median. But do I care about medians right now? No, I just want my orthocenter, which means I need to have a point of intersection of altitudes. So let's see, my R goes down to the 90 degrees. So that means this is an altitude. So this is what? V. My answer is V. That's it. Okay. So now let's take a look at this one. What is this? Name an altitude in triangle GBI. So this whole triangle, what's an altitude? Well, find an altitude, I'm gonna look at my vertex. Okay, this G is a vertex. Okay, if this G goes to the opposite side, which it does, it looks like it's going there, does it form 90? No, it's a median because of this, so it's not an altitude. Okay, let's look at my I. It's going down, 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 down. It's nothing. There's no 90, and there's not even any bisection going on. So it's just a useless line segment. Now let's take a look at the other vertex, B, down to the opposite side at a 90 degrees. So my answer is BD. That's it. Okay. Now, orthocenter. Let's do this one. So I'm gonna draw my triangle because it's telling me to draw. It's telling me my orthocenter, so I want to draw it. So A 0, 0. B is 9, 0, and C is 9, 4. Okay. So what type of triangle do I have here? This is a right triangle. Why? Because I have a horizontal line, a y equals 0, and I have a vertical line, and x equals 9. So I know that that's a right triangle, right? What do I know about a vertical line and a horizontal line? They intersect perpendicularly, okay? So remember we talked about your circumcenter is the midpoint of your hypotenuse, somewhere over here, I'm assuming. So actually let's not do that. So this is where your circumcenter would be. What about your orthocenter? So the same way that your circumcenter is the midpoint of your hypotenuse of a right triangle, your orthocenter is the vertex, is the orthocenter is the vertex of the I'm so sorry. I'm trying to think of like the best way to say it. Your orthocenter is the vertex that contains your 90-degree angle. So your orthocenter here is automatically, I already know my orthocenter is going to be 9, 0. This is my orthocenter. But let's see why it is the case. So remember that for your altitude start at a vertex and go to the opposite side at a 90 degree. So let's take a look at this. Let's take a look at this C. Let's lock into the C right here. What is the opposite side length of this C? Line segment AB, correct? This one, right? So what is the slope of this, or what type of line segment is this line segment right here? It's a horizontal. So what did we talk about? How do I have to intersect the horizontal line to get a 90 degree like the altitude wants it? I have to do vertical line. So I have to go straight down. Okay, and that'll give me my right angle. So what do I know? What is the equation of a vertical line, of this vertical line that I just drew right here, passing through the vertex? Vertical line is x equals c. What is the x in this case? 9. So my x equals 9. So I'm going to keep that there for now. Now let's take a look at another vertex. Let's lock in on A. If we locked in on A, what is the opposite side to angle A? It's segment CB. What do I know about CB? CB is a vertical line. What do I have to draw then to get a perpendicular, to intersect it at a perpendicular like the altitude wants me to? I have to draw a horizontal line. So then I'll get my 90. So what is a horizontal line? What's the equation of a horizontal line? Y equals C. And what is the y in the A? Because remember, I care about the vertex that I'm starting at. My altitude has to pass through the vertex I'm starting at here, if it was this case. And then here, the C, when it was this case. So what is the y here? It's 0. So if my line has an equation, so if my two lines intersect to form my orthocenter, I'm going to make these two lines intersect. And what would that be? It would be 9, 0, which is exactly what my B was. So this is the steps. This is the long way of how to do it, the right way. But this is the shortcut if you understand that. I've done this a bunch of times, so I don't mind if you guys use the trick, the shortcut for now. But if there's ever a question where it's not a right triangle, you're going to have to do these steps, okay? And just for fun, guys, let's find the circumcenter. So if this is my orthocenter, this is my orthocenter right here, right? Ortho. let's find my circumcenter. So my circumcenter is the midpoint of the hypotenuse. Well, what is the line segments of my hypotenuse? 0, 0, and 9, 4. So what is 9 plus 0 divided by 2? 9 over 2, which is 4.5. What is 0 plus 4 divided by 2? 2. So my circumcenter for this triangle is 4.5, 2. So it's going to be like somewhere over here. Okay? So that was just a little bit for fun, just to go back on the circumcenter aspect. You can find the circumcenter of any right triangle by finding the midpoint of its hypotenuse, and you can find the orthocenter of any right triangle by finding the coordinates of the vertex that has the 90 degree in it. That has the 90 degree. Okay? So let's look at this one. Okay, so find the coordinates of M, the midpoint of BC. So to find midpoint, we need to do our formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so what is 5 plus 9 divided by 2? That is 7. Okay, so what is 4 plus 12 divided by 2? That's 8. So I also could have just looked at this 7 and then this 8, but I just really wanted to use the midpoint formula once again for you guys. So 7, 8. Okay, so that's the first part of my answer. Find the coordinates of M, the midpoint of 7B. Okay, so now that I know that M, I should probably write this down. M is the midpoint of my BC. What else do I know, guys? Well, if M is the midpoint of my CB, this midpoint, look where it's connected to. It's connected to a what? Starts with a V, to a vertex. So what do I call a line segment that starts at a vertex and goes to the midpoint of the opposite side, of its opposite side? That's just a median. So I know that I have a median right here. Right? Okay, just gonna leave it like that. So I know that I have a median, right? So let's see what it says. Find the length of median AM. Okay, well, what do I know here, guys? What is this length? They want you to use this crazy distance formula, plus y2 minus. They want you to use this crazy distance formula. But do you really have to? No. Why don't you have to? Are we changing our values of x at all? No, I'm not changing my values of x at all. Look at my x, 7 and 7. So I'm not changing the value of my x whatsoever. So I just have a what? A vertical line. And remember we talked about in the beginning of the year that the way you can find the distance of a number on a number line, the distance of a number on a number line is just by finding the absolute value of the difference of those coordinates. So in this case, I would do y2 minus y1 absolute value because I just have a vertical line. If you had a horizontal line, you would do x2 minus x1. So what is y2? What is 2? Let's say this is y2 and we wanted to make this y1. What is 2? y2, what is 2 minus 8 is negative 6. And what's the absolute value of negative 6? 6. So my answer is 6. And I also could have just counted 1, 2, 3, 4, 5, 6. But I wanted to show you guys how you can use the distance, the simple distance formula. This is the distance formula to find the length of a vertical line. And this is the distance formula to find out the length of a horizontal line. But if we really, really, really wanted to use our distance formula, like if you guys were just like, you know what, I have the distance formula on my answer sheet, on my reference sheet, I'm going to use it. Like, forget it, I'm just going to use it. So you could do that. So what is x2 minus x1? So let's say this was x2 and this was your x2. What's 7 minus 7? 0. Plus, what is y2 minus y1? We just said it was negative 6, right? So now, what is 0 to the 0? 0. I'm not even going to put it, just 0. So now, what is negative 6 times negative 6? 36. What is the square root of 36? 6. So you can use it. But because there's not going to be any change in the x in this case, you'll just get this answer of your y. Just like if there was no change in the y, you would just get your answer for this. That's why you don't have to use this whole complicated formula when you just have a distance of a vertical line or a horizontal line. Okay, so I know that the length of my median is what? 6. Okay. Find the coordinates of your centroid. Guys, this is the part that tricks up a lot of people. Where is your centroid located? We know that our centroid is located 2/3 of the median from where? From the vertex to the midpoint of the opposite side. The centroid is 2/3 away starting at this point. So what is 2/3 of the whole distance? What is 2/3 of 6? 4. So we just have to count 4 up. What is 2 plus 4? 6. So my centroid is going to be at 7,6. 1, 2, 3, 4. That's the other way you could have done it. So now I know that this is my 2/3 version of the median, a portion, and this is my 1/3. You also could have done, instead of counting your 2/3 from your vertex, so I know from the vertex, I know that from the vertex to the centroid is 2/3 of the way. So what is 2/3 of 6? 4. What direction am I going? Up. So I'm changing only my y. So I'm staying at my x, and I'm going up by how much? 4. You could have also done it in reverse. I don't know why you would, but you could have. So to go from my midpoint of the opposite side to my centroid is how much portion? What's the portion? 1/3. What is 1/3 of 6? 2. So what is 8 minus 2? 6. So I would have kept my same x, right? Because I'm going just down. And now I would go 2 to the bottom. So instead of 8, I'd have 7, 6. So I'd have 7, 6. Either way, you're still going to get your 7, 6 answer. Okay? So we should all know how to do this, okay? Okay. So in the diagram, QS and RT are altitudes. Okay, so in the diagram, line segment QS and line segment RT are altitudes, and measure of angle P equals 67. Find measure angle PQS. Okay, so if I want to find an angle, I'm going to start drawing some angles on my triangle, because that's a lot of information, and I have nothing given to me. Like, there's literally nothing here. Okay, so QS and RT are altitudes. So QS is an altitude, which means what? I'm going to have this, and I'm going to have this. 90, 90. Also RT and RT. And what was P? 68, I think? 67. Okay. So now what is the angle that they want me to find? PQS. So PQS. So they want me to find this angle right here. PQS. Okay. So they want me to find PQS. So they want me to find this guy. Okay, so how can I go about doing that? Well, this is a tricky question because you have to start looking at how many triangles you have and what properties of triangles and angles that you can actually use. So how many triangles do I have here, guys? I have 1 big angle, 2, 3, 4, 5. I have a bunch of triangles in here. But what is the one angle? What is the one triangle that I actually know at least 2 of the 3 sides, so I can actually find it? So let's take a look at ROQ. Do I have any angles here? No. So how can I ever find any other angle here? Let's look at RTQ, right? Let's look at RTQ. I don't have an R. I have a T, but I don't have a Q. I don't even have the whole Q, even worse. So I can't use that. So now we have to actually start thinking about what triangles do we see and which one do we have 2 of its 3 angles. And the first one I notice is that I have RTP. Look at this, RTP. I have this 90 and this 67, but I don't have the R. But do I want to find the R? No. So kind of useless there. But what else do I have here? Look, I have this triangle right here, PQO. And what do I know about PQO? I have what? Let's draw this out. Or PQS, I apologize. I'm gonna pull out this triangle. Whoa. I'm gonna pull out this triangle onto here. So I'm gonna have this S, P, Q. So what is my P? 67. What is my S? It's the 90. It's the 90, guys. And now what is my Q? How can I do that? I can do, let's give this a Q. So now I have 90 plus 67 plus Q equals 180. So 90 plus 67 is 157 plus Q equals 180 minus 157. So my Q is equal to 23 degrees. That's it. So my Q is 23. That's it. Okay. So I have a very similar question. I don't know why I put 2. I guess, I don't know. I don't know why I would put 2, but same thing, guys. Same steps. So let's start implementing. So QS and RT are altitudes. QS, RT, P is 63. What is my measure of ORS? ORS. Oh, okay, I know why I did this one. We don't have to, don't worry about this one. Don't worry about this one. If it's on your test, I'm not gonna test you on this one. This one's a big possibility. This one, nah, I'm not gonna do that. Okay, so guys, this is the last one of 5.3 because I purposely put this in here because it's really not hard, but because there's so much information, it's gonna trick you. So ABC has all these vertices. AM, so line AM has an equation, is described by this equation. BN, I'll do it in red. BN has that equation. Okay. Find the coordinate of P. Guys, what is the coordinate of P? P is just your what? Your intersection of the 2 lines. And how do we find out the coordinates of an intersection of 2 lines? We just put them together. So y equals 3 over 2x and y equals negative 12x plus 36. All we're going to do is just put them together. We're going to substitute this 3 over 2 onto here. Because if y equals 3 over 2, then isn't this y and this y the same exact y? Yes. So we're just going to substitute that. So we're going to do 3 over 2x equals negative 12x plus 36. So I'm going to add 12x to this side. So 3 over 2 plus 12 over 1. 12 over 1. I'm going to multiply everything by 2 to get the same denominator. So 3 over 2 plus 24 over 2. That's going to give me 27 over 2. So I'm going to have 27 over 2x equals 36. Now instead of dividing, because even though this 27 over 2 is multiplying, I'm going to multiply by the reciprocal instead of dividing. So 2 over 27. I'm going to multiply by 2 over 27. What is this? 90. Okay, so the greatest common factor is 9, so I'm going to divide this by 9. 9, 18, 27. So this is really going to be a 3. 9, 18, 27, 36 is really going to be a 4. So I'm just going to have, what, 8 over 3? 8 over 3, so my x is going to have a value of 8 over 3. And now to find my y, I'm just going to plug in this x over 3 into any one of these two equations. So I'm going to plug it into that one, to the first one, to the equation of am. So now, what is it? 3 over 2. So now y equals 3 over 2 times 8 over 3. This cancels out, so my answer just, this is going to cancel to a 4, it's going to cancel out to a 1, so my y is just 4. So my answer is 8 over 3, comma 4. That's it. That is the point. And 8 over 3 is about what? 3.6. It's about 2.6, something like that. Yeah, and look, it kind of works out, 2.6. So 1, 2.6. It's around there. Okay. So what is this? 5, 6, 7. Yeah, 4. Yep. So it checks out. So there you go, guys. So that was probably, I know that was really long, but I think it was important. 5.3 was the one that a lot of people had